Welcome to the series that takes you to the heart of America and reveals the inner workings of our country as you have never seen them before. We're going to go on quite a journey. We'll travel coast to coast across this sprawling land to discover the habits, the rhythms, and the secrets you only notice when you step back and see the big picture.
I'm Yul Kwan. I've worked in law and government, business and journalism. I've even won the reality show Survivor. And in every part of my life, I've been fascinated by the same things: systems and networks.
None have shaped us more profoundly than the ones we use to manufacture, to build the things that fill our lives and fuel our economy. Whoa, this place is hot! In this episode, we'll uncover a revolution, a transformation that's well underway, reshaping who we are and what we make.
We'll enter a surprising world of constant change, ruthless competition, and relentless innovation.
I love the robots.
Yeah.
Step back just a little bit.
From the simplest steel screw to the sleekest new car, from a tiny silicon chip to a behemoth aircraft carrier.
We'll explore the interlocking chains of supply and demand, part and assembly, material and manpower that make our country work. 15 seconds. Ah! Here, just finish it for me. This is a story of how America creates. This is America Revealed.
America Revealed is made possible by the Corporation for Public Broadcasting and by contributions to your PBS station from viewers like you. Thank you. Manufacturing has shaped America. From shore to shore, our identity has been defined by the things we make and the way we make them. But manufacturing is not what it used to be. And this place shows why. This is Savannah, Georgia. It's been a trading center since colonial times. And today, it's one of the fastest growing ports in the United States.
Things have changed since the days of settlers, corn, and cotton. These giant ships come here from all around the world, filled with all kinds of manufactured goods, like computers, ovens, flat-screen TVs, and even American flags.
We used to make these things ourselves. Now they can be made more cheaply abroad, so we import them, packed tight inside these containers. We import so much, in fact, that these docks are loaded with more than $130 million worth of goods. And they won't be here for long. Because this port runs 24 hours a day, 7 days a week. So before you know it, every container you see here will be gone, headed off to stock America's stores.
These ships will be gone too, but what they take with them may surprise you, because when they go, they'll be filled with America's biggest export. And it's not TVs or computers or ovens.
It's something else. This is the only warehouse in the port that stores American-made goods. It's the size of 7 football fields. And right now, all it holds is paper. Rolls and rolls of paper. That's because we ship more containers of paper to the world than anything else by far. And one man is responsible for keeping it all moving.
So Larry, everything in here is going to be exported out of the country?
That's correct. Here, in this particular facility, we do nothing but export paper.
Larry Gurkis manages this warehouse. He knows where all the paper comes from, where it's going, and why.
It's going to go to Asia, parts of Europe. A bulk of this goes to China.
And what do they do with all this paper?
Well, it comes right back to us in boxes. All these different electronics that we import from China is boxed up with this paper we send over to them.
So all this paper is going to China. They take it, they make it into boxes to package all the stuff
That's
to import
correct.
back into this country.
That's correct.
So it's just kind of going back and forth.
That's right. Well, I would say you hit it on the nail.
Looking around, this place seems like a sign of troubled times. Paper is what's called a low-value good. It's a product, unlike, say, a television, that's worth little more than the raw materials that go into it. So for many of us, this is an unsettling picture. A picture of a country that's importing more than it's making. Of a manufacturing system that's dying. But if you look beyond this port, you'll see something very different. Manufacturing is not really disappearing from America. It just doesn't look like it used to. A whole new landscape is emerging, filled with new ideas, new people, and new places. Like here, Chattanooga, Tennessee.
This site, from a logistics point of view, it's a beautiful site because it's adjacent to an interstate. You don't have any nearby residential. It's got dual rail access. It's just a terrific site.
This is Dennis Cuneo. He works as a site selector, helping companies find locations for their factories. He specializes in high-value manufacturing, in goods that are worth far more than the cost of their raw materials. And here is what he's so excited about. It's America's newest auto plant, a $1 billion state-of-the-art facility filled with all of the latest technology. But this factory wasn't built by Ford, Chrysler, or General Motors. It was built by Volkswagen. And while you may not think of Volkswagen as an American car maker, maybe you should. These cars are made in America, out of American-made parts, by newly hired American workers, and have been specially designed to be sold in American markets. And Volkswagen isn't the only foreign company being drawn to our shores. What's happening here is part of a much bigger picture. This is what America's auto industry looked like in 1980. Each dot is a factory run by a U.S. automaker. And in the last 30 years, more than half of them have closed. While companies like Honda, Toyota, BMW, and Nissan have opened new factories, spawning a vast network of American-owned auto supply firms, all these dots you see here. It's been a major boost to our economy and a profound change to our auto industry. A change that Dennis Cuneo has witnessed firsthand.
Most of the new plants built in the United States over the past 20 years have been by foreign auto manufacturers. They have put about $44 billion of new investment in the United States. They employ about 80,000 people.
I think a lot of people would be surprised by that because I think the common assumption is that all these manufacturing jobs are going overseas to places like China.
The labor-intensive, low-cost, low-wage cost jobs are going to China. But the high-value-added jobs are still staying here. And the fact that this large multinational corporation, very sophisticated, can build these cars anyplace, has chosen to put a $1 billion investment here, tells you that the United States is still a good place to build stuff, especially high-value-added stuff.
There's one obvious reason that America attracts this kind of investment. We're a huge market. We buy more than 12 million cars a year. But there's another reason that's far more significant. Our factories are in the midst of a revolution. They've embraced a new way of thinking about manufacturing, one extraordinarily focused on efficiency. And here at Volkswagen, you can see that thinking in action. Businesses have always cared about efficiency, but this place has put efficiency on steroids. To be profitable, these people need to make 500 cars a day, and each car has about 20,000 parts. So every movement is coordinated, every action plotted out. Some of this may look familiar because the basic workflow was established over a century ago. Back in the days of the Model T, when Ford auto workers first installed interchangeable parts on a moving assembly line. But don't be fooled. Here at Volkswagen, the assembly line is being utterly transformed. And at the center of it all is something that Henry Ford never dreamed of. Robots. There are robots everywhere in this factory. Welding, painting, riveting. They do more than half the work in the plant. And in many areas, they do all the work. Which is just fine with machinists like Vicki Holloway.
What's the stuff that you do versus what the robots do?
What I'm doing is just getting it ready.
Getting it ready for the robots to work on it?
Getting ready for the robots to work on it, right?
Okay.
The robots do the work. Each robot know exactly what move to make.
Okay.
And then they're finished.
Okay.
And then they're waiting on the next car. It's great. I love the robots.
Yeah.
Step back just a little bit.
All right.
Okay.
Robots do things that are dangerous and difficult, things that require tremendous precision, and they do them fast. The result? Incredible efficiency, but many fewer jobs. It's caused a radical shift in the way our country works. 20 years ago, American manufacturing looked like this. Each dot represents 1,000 factory workers. Today, a third of their jobs have disappeared. And in some places, that number is even higher. Detroit has lost almost half its manufacturing workforce. This is why many people think America doesn't make anything anymore. But that's not true. Because if you look at our country in terms of production rather than employment, you'll see something very surprising. These bars represent the value of what American workers made in 1990. And this is what they make now, nearly twice as much. Over $1.7 trillion worth of goods each year, more than China, Germany, Japan, or any other country on Earth. We've entered a new era of hyper-efficiency. Our factories are producing many more goods with fewer people. And all this has resulted in a new kind of auto worker.
You're yellow, I need a red.
To understand this new worker better, I've come to Volkswagen's training center. It's the first stop for all their new employees. And today, training starts with a game.
So I want 10 trucks, 7 minutes, push system. Ready? Go.
The man in charge is Albert Grazer, Volkswagen's master trainer, part philosopher, part drill sergeant.
We got a minute into this, I don't have a truck on the table.
He's put me on an assembly line with 5 other people and given each of us a simple job. The idea is to see how we can do it better. Putting together 10 in 7 minutes sounds easy, but it isn't. Everybody's struggling, that seems to be the whole point of the game.
All right, he's waiting on you.
This is stressful.
It's stressful.
It ain't easy.
2 minutes and 4 seconds. We got our first truck. We need 10. We need to go. You see this here, right? I've got 3 trucks, 3 trailers waiting for cabs.
Sir, yes, sir.
We've got 40 seconds left. We have 30 seconds left. 15 seconds.
I'm the holdup.
Come on, I need another truck.
Here, just finish it for me.
All right, time, everybody stop. All right.
In the end, Albert doesn't really care if his new employees can build toy trucks. He wants them to understand how the factory works so they can improve it.
This gentleman, as he was putting the rims in the tire, he would pick this up from here and set it on there and push that down. There's no value in that. The time that it takes him to pick this up and put it back and forth is unnecessary in that. What I want him to ask me for is to recognize if this was permanently mounted there, he could completely eliminate them steps, saving a lot of time.
And that's a little bit counterintuitive for me because I always thought the whole industry was moving towards automation and that the role of the individual is slowly diminishing. But what you're trying to do is sort of the opposite. You're trying to empower these employees.
Yes, because robots can't think for themselves. Somebody still has to program the robot. Somebody has to tell the robot what it needs to do. And the only way we're going to know that is to get people to recognize where there's waste.
The lessons Albert is teaching his workers echo well beyond these walls. They're part of a new philosophy that's impacting every industry in America, including one of our most dominant. The arms industry. America makes more weaponry than every other nation on Earth, by far. From missiles to submarines, fighter jets to spy balloons, we spend over $400 billion a year just making arms. That's 6 times more than any other country. But historically, this enormous industry has been plagued by inefficiency. From 2008 to 2010, the U.S. defense budget had $135 billion of cost overruns. And with a ballooning national debt, arms makers are under pressure like never before. This is the USS Gerald Ford, a nuclear-powered aircraft carrier lying in a dry dock in Newport News, Virginia. Even though it's budgeted to cost $10 billion and will be the most advanced aircraft carrier on the planet, looking around, this shipyard looks like something from a bygone era. But looks can be deceiving. Beneath all the rust and grime, this place is starting to change, dramatically.
So this is our main machine shop. What you're looking at here, these are the propeller shafts that connect the main engine to the props at the end of the ship.
How long has this building been here? It looks like it's been around for a while.
Yeah, this building's over 100 years old. Part of the fascination of this business is the kind of the dichotomy of the old and the new. You have these old buildings, some old facilities, and you're doing some of the finest machining in the world.
Engineer Tim Schweitzer is working to change the shipyard by using the same approach as Volkswagen, a philosophy called lean manufacturing.
It's a term that came out of the car industry. But to us, it's all about trying to identify and cut out as much waste as you can to lower your costs and improve the efficiency and the speed by which you do your work.
So basically you're trying to get rid of all the fat in the whole process.
That's exactly right.
So what are the things that you're doing now that were different from before?
We used to do what we call stick-built carriers, and you build every piece into the dry dock and build a carrier from the bottom up. Now you see we do a lot more modular construction.
What Tim's doing is to use the lean philosophy to reinvent the way warships are made. In the past, they were built like this. The hull was constructed first in one big frame, and everything else was built into the hull as it went up. The work was slow, complicated, and cramped. This is how ships are built today, in hundreds of separate pieces spread out across the yard. The site is now so sprawling that foremen like Lawrence Darden have to ride bicycles across it. because it takes too long to walk.
So Lawrence, what do you and your crew do here?
What I do is similar to putting a house together. You know, you got your home, you got different rooms, and I put all the pieces together until we complete the whole ship. It's very cost efficient, and it saves a lot of time.
To keep Lawrence and his crews as lean as possible, the engineers here have developed their own computer software, a kind of virtual reality blueprint system that allows designers like Brian Anderson to plan the installation of each piece of the carrier. Commercial shipbuilders have been using this type of software for years, but in this tradition-bound industry, it's revolutionary.
The predecessor of the Gerald Ford was done in pen and ink. So they would draw ink and vellum, and they would draw the drawings. The problem with the ink and vellum was the guy designing the piping system would pretty much design in a vacuum. He wouldn't know what everybody else was doing. And that's exactly what the 3D product model gives you, is you get all of the systems in the space at one time, and you start to see where the systems interact and where there are fouls.
Okay.
So this piping system designer, he'll be able to see, do I clear this fire main system?
And this prevents you from finding mistakes too late downstream.
Correct. The main thing of it is when we find them here, it's much more efficient to correct them while they're still digital data before we're actually cutting the steel.
It's too soon to tell if the carrier will come in under budget. But the lean philosophy has already saved the shipyard hundreds of millions of dollars, showing that even America's most traditional industries are embracing efficiency. But sometimes, improving efficiency alone is not enough. To survive, some industries have had to abandon everything they do and radically reinvent themselves. This is a scrapyard in Decatur, Alabama. 140,000 tons of rusting metal baking in the summer sun. Waylon Daniels' job is to keep it all organized.
We have different types. Like this right here is shred. It's basically just shredded up automobiles. And we have plate and structural steel. It's like from bridges, ships, barges, buildings, rail cars that are out of service, they cut them up.
This place might seem like a wasteland, but what you're actually looking at is a rebirth of America's most iconic industry, steel. For more than a century, we were the greatest steel-making nation on Earth. Then, we grew stagnant. Foreign competitors began producing steel that was better and cheaper. And in the 1980s, America's steel industry simply collapsed, costing over 300,000 jobs. But looking among the ruins, one tiny company saw an opportunity and seized it. The company is called Nucor. As America's steel giants fell, it pursued a maverick strategy, buying up scrap metal yards like this all across the country and focusing its entire business on recycling.
So these mountains of junk are actually raw materials, and they're so important that this scrapyard was built right here to feed that steel mill.
It was an enormous risk. Steel was traditionally made from iron ore, and scrap was a fringe ingredient. It was cheap and plentiful, but nobody knew how to make it into profitable steel. Solving that problem was Nucor's big breakthrough. The secret, they discovered, lay in the most basic part of the process: heat.
Right now you're looking at the furnace, electric arc furnace.
Okay, so the scrap metal gets put over here, and then you guys melt it down.
Exactly.
Dwayne Thomas supervises the melt team here. His job is to make sure that each load of scrap is heated to a precise set of specifications, which means he's constantly on the move between a tiny air-conditioned control room and the 3,000-degree furnace.
Oh, this place is
some people do, I haven't yet. I just got used to being hot and sweaty all the time.
This electric furnace is key to Nucor's innovative strategy. In a traditional steel mill, furnaces are powered by burning fuel and can take days to reach the right temperature. This furnace, which is heated by electrodes, can power up or down in a matter of hours, providing flexibility never before seen in this industry.
Is that the electrode? That is the electrode. So basically there's a big electric current running through that thing. Right, but all around the electrode, it's insulated, so the electricity is directed into the steel.
This furnace makes Nucor highly competitive. Unlike a traditional mill, they can make steel to order at a moment's notice. Which means that the scrap that Dwayne's melting now won't sit idle for long. Before the day is over, it will be poured, rolled, cooled, and stacked for delivery to the customer. So what was rusting junk in the morning is ready to be transformed into a bus, tank, or refrigerator by evening. The process has been a game changer for the entire steel industry. It's made Nucor the most profitable steelmaker in the country and one of the largest recycling businesses in the world. Nationwide, they recycle 1 ton of scrap every 2 seconds. They're a triumph of American innovation, and they're not the only ones out there. This is Chandler, Arizona, home to what is perhaps the most innovative manufacturing site on Earth, an Intel microchip factory. If you own a computer, chances are good that its brain was built in here.
1 foot in, all the way through.
It's extraordinarily difficult to get into this place because Intel is obsessed with cleanliness.
Back a little bit further. There you go.
I have to put on what they call a bunny suit to keep dust away from the microchips. It means I'm spending more than an hour just preparing to enter the factory. But nothing can really prepare me for what I find inside. It's like I've stepped through a time warp into some sci-fi future. There are little robots running all over the ceiling, vents on the floor filtering air to keep the place thousands of times cleaner than a hospital operating room. And there are machines everywhere, manipulating chips that are layered with circuitry that's infinitesimally small.
When I first started, I could look through a microscope and actually see the printed features.
And you can't even see it through a
You can't even
microscope
do that.
anymore.
Not on a regular one, no.
Tammy Westall is one of the top engineers here, and even she struggles to simply describe the size of Intel's chips.
A human hair is 80 microns. 1 micron has 1,000 nanometers in it. We're printing here 32 nanometer technology. So imagine that. You take a micron, right, which your hair is 80 of them, and you even slice that down even further. It blows my mind.
But even though most of us don't understand the details, as Intel has made its chips ever smaller, they've changed our world. In the early 1950s, before microchips, computers were the size of a house. They were powered by circuit boards as big as your hand, and they could only perform basic arithmetic. Then came Intel. Over the last 4 decades, they've built chips that are ever smaller and ever more powerful, increasing the strength of our computers by a factor of 1 million. And they built something else as well. A brand. Think about it. You and I don't buy microchips. We buy computers that hold them. Yet we all know the Intel name. It's one of the most valuable brands on Earth. But Intel can't afford to rest on its laurels. The world is filled with technology companies that are eating into its market share. To stay on top, Intel must continue to innovate. And this is where they're trying to do it. 1,000 miles from their Arizona clean room, in an office park in Hillsboro, Oregon. Here, Intel has gathered a unique team of researchers. These people aren't just engineers. Some, like Brian David Johnson, have much more exotic job titles.
So, Brian, you're a futurist, right?
Mm-hmm.
What the heck is that?
So it's my job at Intel to look out about 10 to 15 years into the future and get an understanding of what people will want to do with computers and computational devices. Now that kind of sounds a little bit like science fiction, but it's actually pretty practical because at Intel, right, we're an engineering company, we're a manufacturing company. And so it takes about 10 years to design, develop, and deploy the microchip. And so it's incredibly important for us to have an understanding today of what people will want to do 10 years from now.
Brian is part of a team that includes ethnographers and anthropologists. They travel the globe studying behavior, looking at how we shop, watch TV, and surf the internet, trying to figure out how to make microchips for things that don't even exist yet.
If people are watching internet video, if people are watching broadcast video, if people are watching all of these things, as Tony was saying, how do you combine all of those together?
This isn't my idea of what a manufacturing company looks like, but that's the whole point. To keep its brand strong, Intel has had to step back from its hyper-clean plants and microscopic production techniques, back into this world, where the things that you and I do every day hold clues to help them keep pace with the market. It sounds daunting, but this is how manufacturing evolves. Companies try things. Some fail, but many succeed. And all across America, I found companies thriving in surprising ways, sometimes in the most unexpected places. This is Lehigh Valley, Pennsylvania, home to Allentown, Bethlehem, and Nazareth. Once a cradle of industry, the valley is now at the heart of America's Rust Belt. A bleak landscape of abandoned factories, the remains of steel mills that couldn't compete, garment makers that moved overseas. Yet hidden amidst all the decay is one company that's blossomed. This is Martin Guitars. If you're a musician, it's as powerful a brand as Intel. Name an artist, they've probably played a Martin. From Hank Williams to Elvis, Bob Dylan, to Kurt Cobain. But while companies like Intel have built their brand by looking into the future, Martin has done it by staying true to its roots. No one knows this better than Willard Silvius. He's been with the company for 46 years and performs its most delicate task, neck fitting.
You're setting the playability of the instrument right there.
Have you ever thought about working at a different company?
No.
Why is that?
Martin's is the best.
It's the best.
Martin's is the best.
What makes it the best? You, right?
No, it's just that. It's tradition.
Looking around, you'd never guess this company has struggled. But it has. 30 years ago, Martin almost went bankrupt trying to stay competitive by expanding and outsourcing. A disaster that still drives its relentless focus on tradition today.
There's a famous saying at Martin, which is stick to your knitting. That's all we do. We just stick to one thing we're good at. We know we're good at making acoustic guitars. That's one thing we know, what we think we're the best in the world. We think we're the best that's ever been at making acoustic guitars. So why would you do anything else?
Fred Green is Martin's factory manager. He runs this place like a mother hen, treasuring the craftspeople that make the brand special.
Morning, Bert.
Hi, how are you?
How are you today?
Okay, how about you?
Hello, hi. Nice to meet you.
Every morning, I come in and grab a cup of coffee and just start wandering the floor and saying hi to everybody. How you doing? Some people say hi, some people don't. They get really focused on what they're doing.
So they're really into their job.
Oh
they're
my God.
perfectionists.
OCD to the max around here. I mean, everybody is just, if it's just not perfect and just right, they just can't let it go.
It seems like you could maybe automate a lot of this stuff, right? I mean, if you can figure out the specifications for the best guitar, couldn't you just replicate that using machines?
Absolutely not. Absolutely not. I play other people's guitars, you know, and you know it's a machine-made guitar the moment you pick it up and the moment you start to play it. You can get a cold feeling from guitars that feel too machined.
Right.
And guitars where somebody's sitting there and they're shaping that brace, and it's just a little bit different than the last one. You know, they're in the same spec, let's say, but it's just a little bit different.
Fred may seem old-fashioned, but he's developed a clever business strategy. He knows that Martin can't rely solely on tradition. New instrument makers using new technologies are springing up all over the globe. So Fred's carefully refining Martin's factory, adding machines that increase productivity without sacrificing quality.
The jobs that were crucial to the way our guitars sound and the way they feel, we didn't want to change those things.
Okay. So you've tried to automate the non-value-added parts, one that just requires kind of brute machinery.
Right.
But the ones where you actually require a high level of human skill, you try to maximize your production by applying those to the areas where it's most needed.
Exactly.
What happens if someone's working at a job that ends up getting automated or replaced? What happens to the workers?
We just find another job for them in the factory.
Or you keep them in-house?
Yeah, we never let anybody go. When we do hire people, I always tell them our intention is to hire you for life.
Really?
And when you get here, you're not going to leave. The Hotel California, you check in, but you don't check out.
Fred has increased Martin's productivity by 40% without dismissing a single worker. It's an inspiring story. And this place embodies the most basic thing I've learned about American manufacturing. It's thriving. We make a tremendous amount of stuff. And I'm not just talking about acoustic guitars or automobiles or microchips. We're making airplanes, farm equipment, pharmaceuticals, and more. Despite whatever you may have heard, America is actually the #1 manufacturing nation on Earth. Some of our most traditional industries are riding a remarkable wave of innovation, and new ones are springing up all the time, spurred by something that's changing everything about what we make. But to get a good look at it, you need to leave the floors of our factories and head to a remote place like this. The high desert above Ten Sleep, Wyoming. This is one of the most isolated places in America. About 2,000 square miles, dotted with a handful of towns, none with more than a few thousand people. It's a stark landscape with one striking feature. This narrow trench that's being cut into the ground. You see, this trench is as important to manufacturing today as the railroads were in 19th century America. Because it holds something that is connecting every home in this remote area to the world. Something that's distributing goods and ideas on an unprecedented scale. Fiber optic cable. It carries a signal for television, phones, and the internet. And no one is more excited about it than Rod Collingwood.
When our nation started the Interstate Highway Act, instead of having local commerce, we could get goods coast to coast, top to bottom. Fiber optic is the future highway. It allows you to do that same thing on a global scale.
Collingwood supervises crews in this area, driving hours each day to keep the cable coming.
We're continuously building. We have a plan to try and build at least 2 communities a year with fiber to the home.
That's amazing because you're kind of in the middle of nowhere.
We are in the middle of nowhere.
But you guys have some of the most advanced technology, some of the most advanced infrastructure in the country.
That's right. The trend of our current generation and generations to come demands connectivity at all times. Yeah. I don't think there's any way to stop it. I don't think it should be stopped. It's evolution. I don't think the next generation will even know what a post office is.
A what? A post office?
That's exactly right.
Rod's crews have laid over 600 miles of cable. And that's just one small part of a communications revolution that's unfolding all around us.
The end result is that virtually every corner of America is now connected to the entire world. If I pull up a website on my cell phone, my request will travel to that tower and then down to a fiber optic cable underneath.
And from there, it travels to a routing station nearly 200 miles away, a station that can send my request anywhere by integrating it with a vast network of wireless towers that cover the country, connecting almost everyone. It's the most powerful network in history. And while every nation on Earth has access to it, America is using it in ways that are truly unique, creating products that have never been seen anywhere before. Like the product they're making here. This is the engineering department of a company that's worth nearly $80 billion. A company that's growing by 100% each year, while building a product that no one had even heard of a decade ago. Facebook. The whole thing started in a college dorm room, and if you look around, you might think you're still in college. The walls are covered with graffiti. People come and go at all hours and play games whenever they please. It all shows just how much the internet is changing what America makes, creating a new economy where the raw materials aren't things we take from the earth, they're ideas.
The internet is this amazing distribution vehicle to get people's ideas into people's homes and workplace.
Mike Schrepfer helps run this place, and he knows better than anyone how Facebook embodies a new kind of manufacturing.
A lot of people used to think of engineers as people who would build things that you can hold, right? Like cars or like radios. But all your engineers are building something that people can't necessarily touch.
So I think it feels more ephemeral because you don't get a box shipped to you. But the really interesting technical challenge for people here is, every Facebook experience is totally unique. So when you log into Facebook, you get an entirely different homepage than when I log in, because it's all based on who you're connected with and what they're doing. We're trying to present you kind of your personal newspaper of here's what you might find interesting today going on in your friends. And so that's a totally different experience for every person on the site.
This philosophy is key to Facebook. It may seem like a simple website, but it's really a completely new type of product, and the response has been overwhelming. We obtained data showing how a single Facebook friend request, this blue line you see here, can link someone in Chicago to someone in New York, to people all over the globe, in an ever-expanding network. In fact, if you friended every person on the site, you'd have 800 million friends. That's twice the population of the United States. And of course, Facebook isn't just about friends. It's a commercial empire. Almost every company uses it as a marketing tool. It's even started offering software called Facebook Platform that allows anyone to launch a business online. From gamers to retailers, Platform has created thousands of new companies and billions in revenue.
We have hundreds of thousands of developers, and people are actually, there's jobs now that are created around building around the Facebook platform.
Dave Fetterman is one of the engineers who was recruited to build the platform. He was drawn to Facebook by the chance to create something totally new.
Creating something isn't just about putting pieces of material together. It's also about something showing up today that wasn't there yesterday and improving on that.
Do you feel like what we're manufacturing sort of virtually is just as valuable as what we used to make the old traditional way?
I think that's absolutely true. I come from actually a factory town where we actually, in York, Pennsylvania, we make tons of Harley-Davidsons, and the Caterpillar plant used to be there, and thousands of workers. But the thing about Facebook is the kinds of things we're creating here, it doesn't require all that, because the internet, moving bits, is essentially at this point free, and anyone has the tools to build stuff on the internet.
This is the ultimate promise of the internet age. To succeed, all you need is a good idea. Ideas have always been a fundamental basis of manufacturing. Now, they're becoming the main thing. Want to see proof? Just look outside the offices of Facebook to the neighborhood that surrounds it, Silicon Valley. 70 years ago, this is what it looked like. 600,000 acres of farmland on the fringes of Stanford University. What changed? Everything. The Valley is now home to Apple, eBay, Google, and countless other companies that are world leaders simply because of the ideas they've nurtured. It's a testing ground for visionaries. We all celebrate the successes and mock the failures. And no one knows what's coming next. This is Willow Garage. It could be Silicon Valley's next big startup. They make robots here, but not like any I've ever seen. This thing isn't designed to work in a factory. It's supposed to live in your house. It's called personalized robotics. It's about figuring out what robots can do for us in our everyday lives. Some of these robots have been taught to fold laundry. Others to bake cookies. And this one? Well, this one has learned a particularly useful skill.
Well, thank you, sir. Do I have to give it a tip?
Behind it all is a very unusual business strategy. The software that powers these robots is free. You can download it at home right now. And if you run a research lab, you can buy one of these things at a significant discount. Because in the short term, Willow Garage isn't trying to make a profit. Its goals are much more ambitious. This is Steve Cousins, the company's CEO.
A lot of companies, they develop intellectual property and they want to keep it kind of closed. They want to own it so that they can profit from it. But your model is very different. You're sort of giving all your innovations out to the rest of the world. Why are you doing that?
We want to get computers out of the server rooms, and we want to get robots out of the factories. And we want to see those things come together in the real world. And we think that we can be a catalyst by doing that. We think of it like the PC industry. There were early products that were really expensive, and then the PCs came out and really started to take off. And we think we're in the days of those early products now.
So you're saying that Willow Garage isn't being driven by kind of quarterly profits. There's no real market right now for your products. You're trying to create a new market.
We're trying to create a whole new industry here.
But creating a new industry from scratch isn't easy, especially when your product is so complex. Robots work very well in structured situations. That's why they're so useful in factories. But in the ever-changing environment of the human home, robots struggle.
Take that.
Oh.
I just took my piece off the table. See, the robot's cheating.
So Willow Garage is constantly revising its work, trying to make their robots more sensitive and adaptable.
Hey, wait.
Oh, aye. Okay, okay.
Okay, this procedure gets the gripper stuck here.
It's a huge gamble, and there's a very real chance that the company will totally fail. But there's also a chance it will become the next Apple or Microsoft. And that's the point. Risk is what drives this place. Willow Garage is risking a fortune because the reward is potentially immense. They could change the world. And while success sometimes seems a long way off, it's amazing what they've already accomplished. I never imagined I'd see anything like this. And it's really just part of a much bigger picture. When I started on this journey, I thought American manufacturing was dying. I'd heard that our jobs had all gone overseas, that we didn't make anything anymore. But there's another story out there, a very different story. And from the first moment I flew above a factory, I started to hear it.
American manufacturing is still number one. It still accounts for 12% of the U.S. economy, employs about 11 million people, and it spurs a lot of other spin-off jobs that are important to the economy. And I can't imagine an America in which the manufacturing sector is not robust.
Everywhere I went in this country, I saw how true this was.
It starts here and then ends up back here. We're taking the old and making the new.
We can do it faster, better, and cheaper than anyone else. And what this means to everyone else in the world is you can go out now and buy a laptop for a few $100s. You couldn't do that 10 years ago, and that's incredible.
I don't know how they can say America don't build things anymore. We do it every day. There's a lot of planning, a lot of thinking, a lot of hard work involved, but as you can see, that's a good view of it right there. America still builds things.
American manufacturing is enduring a tremendous upheaval. Jobs have been lost and companies destroyed. But my journey surprised me. Where I'd expected to see things falling apart, I found them being built. Looking for weakness, I found strength. Over and over again.
It's a misconception that America is not making things like it used to. So maybe we produce less physical things. But in terms of innovation, I mean, where does Google come from, right? Where does Facebook come from? Where does any number of new, the internet, right, comes out of this country? And it's not like that was an accident, right? It's a way that we think about things.
A revolution is unfolding all around us. Our factories don't look like they used to. They require fewer people and make different products. But we manufacture more now than at any time in our history. And there's absolutely no reason to think we'll stop. America Revealed is made possible by the Corporation for Public Broadcasting and by contributions to your PBS station from viewers like you. Thank you.